Good afternoon. My name is Tanmay Kayande, and for the last decade, I've been the trusted advisor for executives from startups to SMBs to enterprise-scale organizations. I've found the patterns and the architectures of those that lead their field. I know because I've designed and developed their systems and processes using AI, platforms, models, and frameworks to positively affect billions of users, and now bring my insights to you. Welcome to Session 8. Last time we learned how chain of thought prompting helps a model reason by following a single logical path from problem to solution. But what if that one path leads to the wrong answer? Today we're going to explore more advanced techniques that don't rely on just one line of reasoning, but on many to arrive at a more reliable conclusion. By the end of this session, you'll be able to first define self-consistency and explain how it improves chain of thought prompting, and second, define tree of thoughts, or TOT, and explain how it generalizes the concept of chain of thought. To do that, we're going to cover two techniques, self-consistency, which you can think of asking for a second, third, or fourth opinion, and tree of thought, which explores many possibilities at once. If you're following along on the white paper, this is between pages 32 to 36. Let's start by addressing the limitation of basic chain of thought. The white paper notes that it's a simple, greedy decoding strategy, where it just picks the next most likely step, and that can limit its effectiveness. This is where our first technique, self-consistency, comes in. Self-consistency improves chain of thought by generating diverse reasoning paths and then selecting the most consistent answer through a majority vote. The process is a simple three-step loop. First, you provide the same chain of thought prompt to the model multiple times, but with high temperature settings. This encourages the model to generate different and more creative reasoning paths each time. Second, you extract just the final answer from each of the different responses. Finally, you choose the answer that appears the most often in your results. Our second technique, tree of thoughts, takes this idea even further. It generalizes the concept of chain of thought instead of a single linear chain. Tree of thoughts allows the LLM to explore multiple different reasoning paths simultaneously, like branches of a tree. It works by maintaining a tree of thoughts where each thought is an intermediate step. The model can then branch out from any of these kind of steps to explore alternative paths, and this makes the tree of thought especially well suited for complex tasks that require exploration. Again, looking beyond the white paper, imagine you're a startup exploring go-to-market strategies to hit your growth targets. Rather than asking, what go-to-market strategy should my company use? Guide the tree of thought with my SaaS company needs to go choose a go-to-market strategy. First, brainstorm 3 different strategic paths they could take. For each path, briefly evaluate the key trade-offs and success likelihood, then compare all paths before making a recommendation. The result is instead of jumping straight to one answer, the AI now explores multiple options simultaneously, evaluates each branch systematically, and compares alternatives before deciding. Let's do a quick check. Imagine you're using an LLM to answer a complex, ambiguous question where even human experts might disagree on the correct reasoning. To get the most reliable answer, would you use a single chain of thought prompt with a temperature of 0, or would you use the self-consistency method with a high temperature? You'd want to use self-consistency. The high temperature will generate different valid perspectives on the ambiguous problem, and taking the majority vote will give you the most probable answer among those diverse lines of reasoning. The main takeaway is this: when one line of reasoning isn't enough, self-consistency uses a majority vote from multiple attempts to find the most common answer, while tree of thought actively explores many different reasoning paths at once. So far, our prompts have just had the model think, but what if the model could actually do things, like search the internet to find information it doesn't have? In our next session, we'll explore exactly that with a technique called REACT, which stands for reason and act. Thank you. I'll see you there.